So let's start. So when I went to Madrid, I went to the Madrid QA Expo. That's where I met you the first time. And before I went, I asked James, who should I speak to at this conference? And James said, well, you shouldn't talk to this guy. Not this guy, not this guy. This guy only talks about automation. You shouldn't speak to him. Oh, Rob is there, he said. And he said, the only thing he said was, you're a nice man. And when I went to the expo and I met you, I reached out and shook your hand and said, my name is Alexander Carlson. James Buck told me to speak to you. And you immediately raised your hands and said, what have I done? and that's and then after that we spoke for 4 hours about testing, and it was such a great pleasure to meet you. And we spoke about what I am very interested in. It's the history of testing, and with you I can speak about the history of testing outside of software. So my question is, where did testing start?
So many people have different views of it. So I don't want to sort of make any broad super generalization here. And my quest personally, I'm not a researcher, so I'm a hobbyist in this area. But I think testing, similar to the technical work we're doing today in testing. So this is right to 2024, where there's people who are doing testing as part of product development now. Similar things I have traced back down very specifically to the 1700s, and especially I think the closest thing we're going to see to modern like regression testing started about the 1790s by the work by Jacquard in creating programmable tests for looms in the clothing industry in France. And these Jacquard looms were programmed. They were programmed devices. They had people program them with punch cards, and then the device interpreted the program and ran it. And they had to test these devices to make sure that they were working properly, that there were no failures, no weaknesses, no lost information. And they came up with strategies to do beautiful regression testing of Jacquard looms in the 1790s. So this is for me, the earliest thing that looks like modern testing.
Right.
But you could argue that in the history of man, every time someone sort of took the scientific method up, like if you go in ancient Rome or ancient Greece or ancient civilizations, and they do something that looks like the scientific method to try to advance science to understand things, like the work of Archimedes and these guys, the scientific method has inherently a testing feedback loop in it, right? You design an experiment, you observe the results, you try to come to some sort of conclusion, which very often leads you to identify what you want to vary. So you try another experiment, and that loop, that scientific method, I think, is the origin story of testing.
Right.
But to get to something that looks like the practice today, 1790s, and it's beautiful stuff. The first time I saw it was in Britain, in the British Museum. They have an old Jacquard loom there with fabric that was made to test the loom. And this test pattern was basically like a checkerboard pattern, and they would be able to make that pattern, and then they would compare to a master of what it should look like to say, did the pattern that we just generated match the pattern that it should look like? And if it matches, then we're relatively confident that the loom doesn't have a defect. But if it's different, then we're very confident that the loom has a defect, and then we can use that to help diagnose what the defect is.
That's very interesting. I also read somewhere that your father, he used test automation for telecom switching systems in the early 1940s.
Yes, my dad, so to give you a little bit of history, during World War II, he was in the Royal Canadian Air Force, and he was actually trained as a mechanic in the RCAF. A lot of stories about that. But after the war, there was in Canada, he's from Canada, the government offered him an education after the war, an education at Ryerson University, what was called the Radio College of Canada. and he became what was at the time like a radio technician was the title. 1946. He went to work for Northern Electric, which eventually became Northern Telecom. Northern Electric in Montreal, and his job was to do test automation of telecom switching using a device which was the Western Electric tape-o-matic test set. And you would put on punch tape your program, and then it would run through the program and simulate real telephone conversations going on and switches going on in a telecom network to basically try to find bugs and problems in electromechanical relay-based telecommunication systems. This device, my dad started using it about 1946, 47, but the device itself predates that by my dad's work by over 5 years. So you're talking about devices that were made basically in the 1930s that were testing complex state systems. I mean, telecommunication switching systems are complicated. Imagine before we had digital computers, how they were all complex mechanical devices that had billions of states that you couldn't possibly try them all. So they would design test programs to do it. And my dad did that. And when I was a kid in the 1960s, my dad would be telling me stories of test automation as a child and listening to what he did and how because he was able to do that, he eventually was promoted into engineering, and eventually he retired in the end of his career as the director of overseas operations for Northern Electric, which I love the fact that the career path started with test automation, and it was before digital computing, but it was just exactly what you see people doing today with like, for example, capture playback test automation, where you're simulating what users are doing, you capture it, you create it, you program it, you replay it, and you look for problems, and that's exactly what they were doing. But they mixed together, the roles were different, so that the activity of testing was the model of it very similar, the tools very similar to what we're doing today, but the roles and responsibilities were very different. And I think this is an important lesson from not just what was testing and how we practice it, but that my dad's job wasn't just to find problems. He had to find, troubleshoot, and help fix the problems. He was part of troubleshooting, debugging, and fixing. It wasn't just find. You had to find the problem. That was a huge part of it is find the problem. But he didn't just write a bug report and then move to the next problem, right? He worked with the engineers to isolate and resolve, basically troubleshooting and debugging. And my dad was a guru through his whole career of debugging systems. Like, he was just gifted in this, and I learned a lot from him in that area.
Right, so they didn't have dedicated testers at the time.
In his time, there were technicians doing testing, but they weren't dedicated testers. They were
Exactly.
part of the team that's troubleshooting and debugging. There were people who did testing, but it was part of troubleshooting and debugging, not part of like a group. You're only testers.
Right. Exactly.
So you were like a technician doing troubleshooting and debugging, which I guess historically probably morphed into, at some time it morphed into a division of labor. Things get switched. But yeah, that's the story of my dad with Northern Electric. I worked the tape-o-matic test set. I've done a lot of research. I've got some articles about it. I've pulled from Bell Systems Journals information. I've got a little bit of marketing literature I found on it, how they tried to sell test automation tools in the 1940s, which is really cool. As it's so similar to what they say today about the tools that they're selling you at testing conferences.
It's the same thing. Yeah.
It's the same ad, just a different device, just.
Right. And when we met, you also spoke about I believe it was after the fall of the Berlin Wall, when Eastern Europe started opening up, and you found yourself, I believe, in a bunker, working for, was it Subway, setting up their payment systems?
Well, there's a couple of stories that are mixed in there.
All right. Yeah.
A bunker involved in this story, and the bunker was military bunker. But there's three things I was involved with. One in Eastern Europe was helping to put, it wasn't Subway, it was a Pizza Hut. And the Pizza Hut in the States wanted to be able to take advantage of the market opportunities in the emerging market, right, of what is Eastern and Central European countries that previously had been blocked to them. And they wanted to parachute in the whole restaurants with the point of sales, the terminals, the telecom things, and they were totally screwed up. Like they had no idea that you can't pay with a credit card the same way in Poland that you could in Kansas City. But all the people who developed the system were in Kansas City, and so I basically had a chance to work on those cool projects. And I was traveling a lot to different points in Eastern and Central Europe and a lot of places in the States. So we were doing I was doing this stuff called virtualization, where we tricked the operating system and we tricked the presentation layer so that people could work in their own language with their own data, with their own methods, even though the system was designed and operating to work primarily in American or Western European data sets and languages. That was a presentation layer virtualization that we were working on, which is pretty cool. This I'm talking about like the late 1980s here. That's ages ago. With the technologies we have today are so beautiful. You can take a system now and work with 57 different languages on the screen at the same time, and it's beautiful and transparent. Back then, that couldn't be done, so you had to trick the operating system and virtualize things, trick them, fool them into thinking that they were in a different context than they were. That's one. The bunker stuff was cool. That was the same type of devices that were being used during this was the first Gulf War. It's a long time ago. These devices were used in command and control. And command and control in military case, people are very concerned about false signals. So let's say you have a device, like the same type of device that you're using to buy pizza in Poland, right? You're using it to sort of say, okay, we're going to send a missile over here. And we want to make sure we're blowing up the right thing or not blowing up the right thing. And how do you test to make sure that you never accidentally give a false command?
Right.
So this is the bunker story now. So to test that, we basically set up a lab which had large electrostatic discharge tables, big sheets of metal, and we would have our device, which was basically character imaging devices, video display terminals, and all the accoutrements sitting on this. Have it running basically loops of pretty for us pretty common, like a simulation of the usage of it over and over again in a loop. We're also simulating all the user entry, so we used we called it robotics at the time, relays to control every input, and we were monitoring the outputs. We're doing all this type of stuff, really nice testing. But because we're afraid of, what if there's a false input, what we would use is electrostatic discharge. And to do that, they would have what's called a cattle prod. It's a long piece of metal, and when you pull a trigger, it gives a shock. So while the device is going on, you shock the device, you shock it, and you try to see, does it give a spurious interrupt to the device? And if a shock causes it to send some information to the host, then you have a risk of a false positive during a military concept, especially, for example, electromagnetic pulses as a result of bombing and stuff like that could cause electronic discharges, which lead to false signals. So that type of testing I did around the time of the 1989, 1990 related to it's the same thing in Poland and same devices, but for different parts of the world. Also did a lot of work in Czech Republic and Czech Republic, Slovak Republic, Hungary, all those countries were the emerging ones at that time, right? They were just the first ones to get what we would, like, I'm from Canada, so it's westernized market economy. But it was fun to be on those projects. I mean, it was crazy. Like everything was, hard to do. You had to use your imagination. You had to make your own tools. It was just fascinating.
That's so amazing. So when you
but I'm glad I was there. I'm glad I did it.
Yeah. And so when you shocked, as you said, that is real stress testing, right? That is what you call real stress testing.
Oh, yeah. That's well, it's not just stress, right? But it's failure modes. You're creating failures, and you're trying to make sure that the device doesn't respond to it in a way that's, inadvertently gives a command. I mean, it might, frankly, I would rather the device breaks down and goes on fire than sending a false command to say, hey, we launch a nuclear bomb. Like, we want the failures to be there. We want the failures to be conspicuous, but we don't want false positives. We don't want the false triggers. And yeah, that's failure.
I want to ask you also, I asked some people what they wanted me to ask you, and one of the questions that came up is the most important bug you ever found. How did you find it, and what would be the consequences if you didn't find it?
It's interesting that the question comes of what was the most important bug that I found, because let me look at it from the point of view important in my career. So this is one of the most influential bugs that I ever found, and it was a bug that required interesting knowledge to figure out. It was a bug in a device that was a graphics card by a company called Matrox. They still make graphics cards today. The graphics card was bus mounted into a type of computer they don't sell anymore called a PDP-11 from Digital Equipment Corporation. In its day, a very popular computer. And that computer was sold with different bus architectures. I don't know if you've heard of bus architectures, but the bus is like your backplane of your computer. And we had some buses were 16 bits and some were 32 bits and some were 64 bits. And people today, they think they see, when you hear about processors, they say, is it a 16-bit, 32-bit, 64-bit? And they don't, as a tester, what does that have to do with my life? Well, it has a lot to do with the software, low-level software, and how the CPU, how the processor communicates with the world. So this bug was that on the 16-bit and on the 32-bit version of the same computer, literally it's both the same computer, but one has got a 16-bit bus, one's got a 32-bit bus. The software, it's the exact same software, the exact same hardware, it failed. It didn't work. It didn't work correctly. And this bug was driving me nuts. I couldn't figure it out. It was very important. It was blocking a release of a graphics project. It was an early windowing system. I actually wrote some papers on it. Like, just really interesting failure that failed on one computer, didn't fail on the other computer, and everything else was like identical. And I was going kabonkers. And then one night I was at home, and unfortunately I lived very close to my office, and I woke up in the middle of the night with the aha syndrome. I had this, what's going on? And I remembered, because I studied in school and I did my work, and I remembered that in some processors, now we're going to the microcode of the processor, the embedded software in the processor, not the software in the driver, not the software in the application, the embedded software. Some of them implemented instructions to move data by moving a byte at a time. So let's say you want to move 16 bits of data. Well, sometimes they'd move 16 bits in one shot, or sometimes they'd move 8 bits and then another 8 bits, right? So it's read, modify, write, 8-bit cycles or 16-bit. And depending on the bus architecture, they would do it differently. But from your program, you don't see that. It's in the microcode. Low level stuff. But I realized that the graphics card was reading the signals on the bus. And maybe they were reading the signals for the words, but not the bytes. So they would be interpreting the 16-bit ones okay, but the 8-bit ones weren't okay. So I designed a little bit of experimental code to try that hypothesis. And I was so excited. I spent like 8 hours just doing beautiful analysis, came up with perfect proof, clean examples of where the hardware was failing and what the problem was and all this type of stuff. And I was so proud. I was so energized because I was able to take my knowledge of hardware, of software, of testing, of every programming, and put it all together. I was just like, wow, what an important, cool bug. And then I share it with the chief engineer that made the graphics card. And he basically, I thought they were going to give me a bonus or something, as praise for what I did. He said, well, it sounds like something that you can fix in software. and of course, because I knew what the problem was, I could avoid it in my software. And so he didn't change it. I basically learned such a valuable lesson from that, because just being clever and figuring out how to hard a bug is not really the key thing. It's keeping business going that matters, and focusing on this. So I did well. I did a good thing. I'm not saying I didn't, but what was influential for me was to really start understanding context, and to really understand that what I thought was fantastic and magnificent and important for them, as long as you could write software to avoid it, who cares? They didn't give a darn. It didn't matter. So that's for me, that was one of the most influential bugs early in my career that I found. And I felt very bad at the beginning, but I started to realize after a while that I was very, very blessed to have such an experience. And still to this day, I meet testers who get very angry because the bugs they find aren't being fixed, and things that I'm saying, well, maybe it's because they know about the bug and they can avoid it, and don't get mad because they can't fix it. Instead, encourage people to make really, really good business decisions. Really, really good business decisions. So
Also,
that's what.
telling people about the risks of not fixing the bugs.
Right. And the risk of fixing it. Right.
Yep.
So risks on both sides. And it's certainly important to frame your bugs as an advocate, right? Advocacy, but frame your bugs from the point of view trying to convince people to fix it. But as a professional, your job, I believe, should be to make sure the people deciding have really good information and knowledge and are making sound decisions based on that, and don't get emotionally attached to the actual decision. It's a trade-off. It's always a trade-off.
Exactly. Yeah.
So
I
that's
also
one example of an bug.
Yep.
I hope that's the type of thing you're looking for. That's very influential for me.
That's exactly what I was hoping for. Also, unusual bugs. That's another question that people want me to ask you. Unusual, you know.
Yeah. Unusual bugs. Well, there's been so many beautiful unusual bugs, and I love bugs. So I get so excited about unusual bugs. There's a story. It happened to me in India about 10 years ago. I was teaching a group of people some exploratory test design techniques, and I have a heuristic that I'm almost always using when I'm testing. Almost always. In fact, challenge me not to. I try very hard. I call it triangulation. And what I try to do whenever I'm testing something is try to identify 3 independent ways to assess correctness. And so just because the number on the screen is correct, it doesn't mean the number in the database is correct. It doesn't mean the number in the report is correct. So I want to try to find 3 ways to say, is this correct? I don't just believe one. I look for 3 independent. And that's me. I don't say you should do that, but that's something I do a lot. So I'm in India trying to teach this approach. And the young guy, we picked a software application that was already deployed commercially, already deployed software application. The tester who had tested it paired with me, and I was trying to teach him some exploratory testing techniques. And after a few minutes, he started really getting frustrated with me. And I was sort of fiddling around looking for ways to assess correctness. And he wanted me to test the software. And I'm sort of saying, I am testing the software. Looking for ways to assess correctness is a very frickin' important part of testing the software. It's not just hitting keys and getting transactions done. It's the cognitive aspect of solving the problem. So anyhow, within a few minutes, he showed me the obvious and his way of assessing correctness. There was a calculation on the screen, and that you could check. And after a few minutes of fiddling around, I found a second one, which was a log file that was generated that I could compare it to. So I had the log file, I had the number on the screen, this too. And there was no third one readily available, but I didn't want this person to be ticked off with me. So I said, let's start testing with 2, and maybe a third will come up. And sure enough, after about 5 minutes, a third one obviously came up because there was an email that was automatically generated by the transaction. So I had the email generation, I had the log file, I had the number on the screen, all 3 of them going. And then we did about 20, I used simple pairwise analysis of some combinatorics live. I'm doing this live, no prep, just an application I had no knowledge of whatsoever. And I came up with a bunch of trials that I wanted to try. And every trial we did it, and we used a couple of scripting tools to help us, but It was just like, I would say, semi-automated. And this whole thing took 45 minutes. It didn't take hours, to 45 minutes. And we found, before we got through those 20 some odd cases I had identified, we found a bug on the live system where there was inconsistencies between the data that were managed and the data that was there. That was the aggregate value of that would have been worth, if it stayed in the system, over $10 million lost to the customer. And we found that just by doing the style of heuristic I used, we're looking for 3 independent ways to assess correctness, and change nothing else, just that. And it was a fascinating experience. And that to me was, and there was live commercial software. So when you're finding a live software bug like that, that's pretty, for me, that's pretty fascinating. And I love that bug. I love the bug because you had the false, as a tester, you have the false impression it's working. And this bug, the class of bug, I started identifying them when there was a piece of software that was created called Crystal Reports. I don't know if you've heard of Crystal Reports. It was a report generator that was quite popular in the 90s, early 2000s. But this was a report generator, and developers used it to make all sorts of business reports, and fantastic. But the problem was that it was so flexible and so programmable that the programmers very often implemented the business logic in the report generator instead of in the application. And so the report was correct, but the data never got processed properly. It was the report that was correct. And it was the false notion that if you checked the output of the report, the application business logic was correct. Well, the report was correct, but the application business logic was not processed correctly. And this is the false positive, right? Of if you have only one way to assess correctness. So I don't know. I don't want to get too distracted from your question, but these are like wondrous bugs. They're just so glorious in showing the weakness of technology and how really, but it takes, I think, smart, clever, cognitive testing to find these things. And if you just, especially today, the crap I'm seeing today is awful. The way people use tools like Postman to test APIs, and I look at what they're testing, and all they're doing is looking and saying, did the API return an error code flag? And I said, what are you doing? Like that is telling you nothing. What if the bug is it doesn't give you the right error code? You know,
Who's testing the automation, right? That's the question. Yeah.
Well, that's part of life, eh? It's who's testing the tester, who's testing the automation. And this gets down to methods of work and peer reviews and
Right.
always trying to challenge yourself and not getting attached to any one technology. So Andy, I don't want to get too distracted from the story of fun bugs, but I could talk for hours about interesting bugs. There's one bug I have a video of that I found live. I found this bug live. This was on Amazon, an earlier version of Amazon. Sometime, I think it's 2007, I found this, where I basically put objects in the shopping cart and Amazon decided to throw something in the shopping cart that I didn't put there.
Really?
Yeah, and I have the full video of this. I turned it into an exercise. I used this at many conferences. Even today, I'll use this exercise because I asked people as testers, like, if this happened to you, what would you do next? And it was beautiful to find it for real. It really happened. It was an interesting bug, and there's a lot of stories around this bug, but that was on a live system. So Amazon throwing something in your shopping cart that you did not select.
They made a lot of money there. A lot of money. Yeah.
Still makes hands over fist. But and I'm sure they fixed the bug since then. But
yeah. One of my questions that I have, which is a personal question, it is about critical thinking. And you're a professor at McGill University. And what I'm seeing more and more is that the testers that I know, and even the testers that I respect, they are critical thinkers when it comes to their job. But when it comes to things outside of testing, they're not critical at all. And my question to you is this. I have this theory that to find the best testers for the future, you should go to the places where the most critical people are. And I believe that they are hiding in philosophy departments. I think that they are, on the fringes of politics. I think that they are, just very, very critical people hiding and we should get them to become testers. Is this something that you've ever thought about doing?
Well, I certainly have in my career and in my continued work found people who are in other domains that just make extraordinarily good testers. And if you want to be very specific, the domain of philosophy and logic and rhetoric, if you've got skills in that area, you can beat the crap out of bank systems, business logic, and you can take those skills and apply them to test design and do a wonderful job. I think that the skill set that I've seen most amazingly used in software testing, though, is not logic so much. It's the communication skills, and this comes from people with degrees in technical communications or degrees in journalism, and with a background in writing and communications, you learn how to basically record what you're seeing, observe things. These people have incredible observation skills and communication skills, and I think those skills frame testing so well. And I've seen people, great testers, who come from those domains. I don't want to necessarily name names of other people, but I'm sure some of them you've heard of, and they come from domains that are not software engineering related. They're not business related. They're not domain specific. They're just people who are good technical communicators, good writers, good journalists, and these guys make fantastic testers. And I've seen great success in that. The failings I've seen, though, also there's risks with people who come from other domains and they get into testing, and sometimes it's serendipitous. So you're in a company, you're working there, and you seem to know a little bit about the business, so they call you, can you help us test this new application? And then you're suddenly you're in the testing department. And there's a story I know about a tester who's taken a course I was teaching, and she got very angry with me. And she was really angry, ticked off with me. I mean, I couldn't say, the student was angry, and I had made a statement quoting Edgar Dijkstra, saying that testing is intractable, complete testing is impossible. That's what I was saying. And she was very angry with me because she thought she did her job very well, and she did complete testing, and she did it really good. And she was upset that I was saying complete testing is not possible. And of course, her view of testing was very limited compared to mine. And so maybe I made a mistake in my rhetoric, but she was mad at me. She was ticked off with me. Anyhow, the class was going on. This happened live in class, so everyone saw this interaction. Several of the students came to me during the break and told me, Rob, calm down, Rob. She's just one of these people with weird background. It worked out. She started working. This is a major American insurance company. She started working in the food service department. And she was very, very good at buying and ordering food for the cafeteria. And then one day, people loved her because they liked her communications was great. She was a good person, people person, right? Then one day the help desk had a shortage of personnel, and they recruited people from other departments to work at the help desk. And because she was such a good people person and loved helping people, she went to the help desk. And she didn't know anything about the insurance application or anything at all, but she was helpful. And so she really succeeded in the help desk. And then one day, the testing department was in a crisis, and they needed people to help who had domain knowledge. So they went and took people from the help desk to work to the testing team. And this person ends up in the testing team, and her boss realizes that this is not a tester, this is not someone who knows very much about testing, but he taught her how to do a type of regression checklist testing that she was going to be able to do good at, and that was her job, was to do that little thing, and that's what she thought the whole world of testing was that little thing. So I look at it, I'm saying she got into testing, she was doing her job, but it was like a weird path. Like she got there as a result of a weird path. She would have been good in food services, and the other path like that, if you see people who go from the help desk to testing, and we see this all over the place, or support department to testing, they're very good at supporting a version of the software. So that version, when they test it, they're very good. They know the business rules, they know the stuff. But as the application evolves, their support knowledge disappears because they don't have the more general knowledge of the more systems-oriented thinking. So I do believe that there's great testers can come from many different domains. Just like in the movie Ratatouille, if you ever watched that movie, is about mice that a rat that becomes a master chef. And great master chefs can come from everywhere, but it doesn't mean everybody can be a great master chef. So I think great testers can come from many, many different domains, many, many different walks of life. They can come from a lot of places, but not anybody can be a tester. It does take, I don't like the word mindset, but it does take, I think, a love of the class of problems that we're trying to solve. A love of it and a willingness to learn. Every project I ever do, every project you ever do is always, there's something new. There's some technology thing, business thing, cool thing, always learning new stuff. Don't get attached. And that's the thing I look for when I'm looking for great testers, people who have, I don't care where they're coming from. Are they someone who's going to want to learn?
Yeah, exactly. And one last question that I have. What I do and what I specialize in is testing beyond requirements. So
Right.
most testers, they get their requirements. Are these requirements within the product? Yes, fine, whatever. And what I've done is I specialize in asking questions about the requirements. Where do they come from? Who says that they are the true, it is the source of truth, right? All these things. And I've gotten a lot of pushback for doing that. And my question to you is that another field? Like, is that a tester's job, or should it be a tester's job? Because what I feel like is if we have a product, right, and bad information goes into the product becomes bad. So why shouldn't you test the information that goes into the product?
That's we could spend another 4 hours on this little, but it is first answer. I'm going to give you a high level answer, but I want to be more specific. I believe that in the evolution of software engineering, that the biggest problem we've ever had and still continue having is understanding, are we solving the right problem? And this is hard to understand. Are we solving the right problem? And that the domain that sort of gets blamed for that is sort of called requirement engineering, which is sometimes related to business analysis, but requirement engineering used to be a discipline. It used to be something that people would say, I am a requirements engineer, and I'm trying to write very good and very complete requirements. So we went through a phase in software engineering where people believed, okay, if we can write that beautiful, clean, all-inclusive requirement, that we would be able to then develop software, do the right software well, and we'll be able to program against those requirements and test against those requirements, and everything's fine and dandy. The trouble is, of course, as we've all learned, requirements changing constantly. And what's the point in making really super duper detailed requirements, right, way in advance, if it's all going to change? So this whole agile universe comes up and it says, well, let's do the opposite. Let's have actually, instead of very, very detailed requirements, a very, very undetailed. I mean, I don't want to say ambiguous, but definitely, not much detail. And then wait till the last responsible moment to detail them. So this is conflicting ideologies in software engineering. And if you look at the Agile documentation for the Agile Manifesto, in Agile Principles, it explicitly says that we don't want to do any upfront architecture in Agile projects. And yet in software engineering and systems engineering, people say, no, that's the wrong approach. You should do an upfront architecture. Make it flexible, but do upfront architectures and work towards an architecture. So this is like anti-agile. And this conflict doesn't help us in testing because we're getting very weak requirements. And we have to basically ask questions, just like you said, exactly the way you're praising it. We have to look beyond what the expressed requirement is and look at what is the real requirement. And the real requirements are not written down. They are almost always implicit. And our job as testers, therefore, becomes people who are truffle snorting pigs. They're going to stick our nose everywhere to try to find out what is the real requirement. And it's not the detail of the documentation that matters. It's the truthfulness of it. That's the point, right? The veracity of it. And so to hunt down truthful things is not something that's one person's job. It's something that's a community activity, and it's an interaction. And believe me, if you can master that part, that little skill set in software testing, you can become a very powerful and influential advocate of quality in an organization. People who are product owners, people who are business leaders need someone like you to basically, before we waste our money programming the wrong thing, say, are we solving the right problem? And then the balance of how much detail do we want in the requirement, that is your team, that is your dynamic. I'll show you hundreds of examples. I'll introduce you to people. Have the dialogue. Don't believe just because someone gave you a ticket from Jira that said a 3-line gherkin script given when then, and it has a little story saying who, what, why. Is that sufficient? The answer is probably not. There's probably a hell of a lot of information that we need to learn so that we can focus on what matters. And looking for those gaps, looking for those omissions has been the quest of many people. There's been many great books and articles written about these topics. And today I see testers not even cognizant of it. So I think you're very wise to bring this up as a problem space. I don't think it's a problem space that doesn't have a solution. I think it's a problem space that is actually reasonably well understood, but not shared, like, and not encouraged too. I mean, I expect the day before COVID, I was at a monster American company doing task analysis of testing. And I interviewed 4 testers. And this is a huge monster company that's huge, influencing everything in the world. These 4 testers told me stories independently. Every one of them, their work was focused on one little teeny weeny ticket. They didn't even know what else the product did. They just said they had their little ticket, and that was what, and they had to do the job. They were being measured on how long it took them to close the ticket, and if the ticket was reopened and all this. It was ticket-driven software engineering, and totally opposite of what you're saying. Like, I look at that ticket, I'm gonna say, wow, what else is going on? Like, what's happening here? And I think people with testing skills and experience, when they read a requirement, they can ask questions about, are there any other factors other than those that are written down that will influence or could influence the behavior of the system? And
where do
this
these
is
requirements come from? Where do they come from? And the biggest pushback I actually got was from a product manager who I haven't worked with, but I was telling him about this kind of testing, which I just call beyond requirements testing. The biggest pushback was the owners and the business analysts and the managers are smarter than you. And I said, you know what? It's not about being smart, because they are probably smarter than me. But the difference between me and them is that I'm trained to be critical and they are not.
Yeah.
And that's
And keep in mind, complement that. I want to complement that with one other thing is there's many people, we're a community, right? There's many people working on the project. And the input from testers on requirements, the input of testers on requirements, and the influence of developers on requirements is very different, but it's both necessary. The developers, when they're critiquing or analyzing a requirement, very often they try to frame the requirement. So they try to constrain it, and they're modeling it on how they want to solve it. And testers, on the other hand, they look at a requirement when they're reviewing it, and they're looking at other factors that could influence it or things that they've seen in the past. And if you take those two type of requirement analysis thought processes and throw them together, you can really get beautiful, beautiful requirements and beautiful, especially before the programmer starts writing the code. You know, I hate to say this, but the tester very often, when they get the chance to be that critical, it's late, right? It's like they wrote the code already. You have some very good questions. You should have asked them 3 weeks ago. You know, where were you? And that's my question is, where were you? Get a seat at the table. You know,
that's what James Buck calls prospective testing. It's being there before you start creating the tickets and everything. Yeah.
And no one's going to tell you that's your job. You got to sort of do it. You actively sneak your way into the right place. And if you ask good questions, they're going to love you and they're going to want you back over and over again. I truly believe that. A good architect, you know, you see these guys, they have beards, they wear checkered shirts, they have long hair. They're wonderful people, these architects. And they basically want someone to ask them a question. They want someone to challenge them. And if you're a tester and you go there and you challenge them, they're not going to get mad at you. They're going to, with time, they're going to actually want you there. They want you to be part of it. I mean, granted, don't tell them how to do their job. Just
Right.
ask questions. And by the way, questioning is also, be careful about questioning. I have seen some testers take this to extremes. They'll talk to me or James and they'll say, wow, I got to question the requirements. So, well, you've got to learn about the requirements. Maybe it doesn't mean you have to batter people with thousands of questions. Maybe you've got to figure other ways to learn, not just, attack with questions.
Ask the right questions at the right time.
Ask them the right way too, so that you're helping people solve a problem as opposed to telling them they're idiots. Like this programmers are very sensitive sometimes. You show them that their code doesn't work, they don't always take it the right way. It's like, be tactful.
Yeah, just being humble and saying please, and please observe that this is happening,
and realize you're building a relationship, and that relationship, and I know after all the years I've been in this field, I know that's going to transcend your company. You're going to work with these people in other projects and other companies in the future. And it's don't burn bridges, just realize that the developer also is getting the same crap, right? Someone is changing the requirements while they're in the middle of programming it. So what am I supposed to do? And then you're testing it with data that the developer didn't even know existed. How could the developer, work with them and hopefully participate in, I guess, in agile projects, sometimes they call it grooming,
Right.
That sort of activity. But whatever it is, just before the team commits to doing a requirement, that's when you just got to sort of dive in there and learn about it and make that a team activity, not an individual activity. That's my guidance to people. It's quite funny because your question started with people from other fields getting into testing and then diving into requirements. And I think these are just so fundamental. I wish everybody would learn about this stuff. I try hard when I'm teaching at school, but still you run into people who just, they just don't get it.
Right. Yeah. Thank you so much for being interviewed. And
it's awesome. I hope you're able to collect our ideas and put it in a form that's useful and